External steps, ramps and contours. Reference GD 1105. On any site with significant level differences, the control of changes in level is important for the appearance, convenience and safety. You need to be able to calculate spot heights, check the gradient of ramps, and to design the rise and going of steps. The seminar defines the terminology and includes exercises in these matters to practice the simple rules of thumb. The rules of thumb which apply to external steps and ramps generally require less steep slopes than steps or stairs inside buildings. Even if you do not consider disabled people will figure prominently among the users of your design, remember that designs which are safe and accessible for the disabled and the elderly will also be more convenient for the hale and hearty. The vertical height from one tread to the next is known as the riser. The front edge of the step is known as the nosing. The length of tread from one nosing to the next is known as the going. This dimension excludes any overhang of the nosing beyond the face of the riser. The projection of the nosing is useful in making a minimum size tread more comfortable for putting your whole foot on. But too large a forward projection of the nosing becomes a tripping hazard. The danger of tripping is reduced if the nosing projects no more than 25 millimeters and is radiused or rounded. The pitch line is the angle between the line of the nosings and the horizontal, and it should preferably be less than 30 degrees for external steps. The rise and going dimensions of a formal flight of steps should be constant. An unexpected difference of only 15 millimeters in the riser can cause people to stumble. People quite rightly expect that formal steps will have a consistency which enables them to walk up and down with a steady rhythm. Adjacent flights of steps should also have identical dimensions. Treads should be level, although a small drainage fall from back to nosing of not more than 1 in 60 would be acceptable. To avoid puddles, this slight fall would also apply to the landings at the top and bottom of the flight, and any intermediate landings which otherwise should be level. There is no specific control over external steps in private domestic gardens, provided they are detached from a building and do not form part of the access route to the house front door. But there is always, of course, a legal obligation to design safely. Natural stone steps, created as part of a rockery, might justifiably be rugged, uneven and steep. But don't mix formal and natural steps to catch the user unawares. In this seminar, I am mainly concerned with formal flights of steps. For many years, the design of internal staircases has been strictly controlled in the UK, with public buildings having shallow steps and domestic buildings being allowed slightly steeper stairs. Although the building regulations rarely affect external steps, it is generally accepted that external steps need to be shallower than internal domestic staircases, partly because handrails are often not provided. My rules of thumb for maximum and minimum dimensions for treads and risers are shown on the screen. The range of dimensions to be used is 120 to 170 for risers and 280 to 450 mm for the going. The physical effort needed to walk upstairs is often expressed in a simple formula: the sum of twice the rise plus the going. If you take the proposed dimensions of your stair in millimeters and apply the formula, the result is a number which should fall within the range 550 mm to 700 mm. The tried and tested assumption behind this formula is that it requires twice the effort to step up by a given distance as it does to step forward. For example, if you decrease the rise by 20 mm and increase the tread by 40 mm, you would still have a flight of steps which took the same amount of physical effort to climb. Stairs where the formula results in a figure near 550, at the bottom end of the range, are the easiest to climb, whilst the resultant figure of near 700 mm indicates a greater effort is required. Having made a provisional choice of dimensions for your proposed stairs and checked against the formula, you should apply a third check to your design by ensuring that the pitch line is less than 30 degrees, as I have already mentioned. On the screen is a sample range of steps, with different dimensions mainly within the limits given in the rule of thumb. The two examples on the left of the screen require considerable effort, but are acceptable because they are less than 700 mm according to the formula. Applying the formula of 2r plus g to the lower example on the right of the screen gives a total of 550, showing that it requires the least effort. But the upper example on the right is unacceptable, because the tread is shorter than the rule of thumb and the pitch line is greater than 30 degrees, even though applying the formula gives the same total of 550. To avoid the risk of serious falls, the maximum number of steps in each flight should usually be limited to 12 and never more than 16 without a landing. 12 steps with a 150 mm rise, for instance, is equivalent to 1.8 meters in height, which is the preferred maximum height without a landing. It is easier to design your steps and then form your bank to fit. It is more difficult to fit a flight of steps to an existing bank. If that is your problem, then it is easier to construct a flank wall or balustrade which can disguise the difference in slope or an uneven bank. The picture on the right of the screen illustrates a flight of steps with a flank wall, where the ground level on the outside of this wall is not seen and does not affect the appearance of the steps. In these less substantial modern examples, the problem is different because the adjacent bank is loose soil sloping in towards the steps. Note the attempt to counteract the problem by either a small string course or by the novel method of tapering the plan shape of each step. Single steps are also a potential tripping hazard because the small change in level may not be noticed. If a single step is essential, ensure that contrasting colour and or texture of the paving gives adequate warning. The examples on the screen give either no warning or misleading signals. Colour contrast or texture change. In the illustration on the screen, widely spaced single steps are identified by a colour change. A texture change can also alert blind or partially sighted people to a potential hazard. Where there is sufficient space, it is preferable to use a ramp to overcome a small change in level. If steps are essential, it is best to use a flight of at least 3 steps. Steps are suitable for external slopes at angles between approximately 15 to 30 degrees. Internal domestic stairs may frequently be found with slopes up to 45 degrees, but as we have seen, this is not recommended for formal external garden design. On the screen are shown examples of external slopes at 15, 20, 25 and 30 degrees. For each angle, a suggested step riser dimension is quoted so that the suggested step dimensions meet the formula of 2r plus g equals 550 to 700 millimeters. The choice between using a ramp or a flight of steps depends mainly on the gradient and the total length involved, as we shall see shortly when we do some exercises. When faced with the need to select appropriate dimensions for a set of steps up an existing bank, it is suggested that the average slope of the bank in degrees should be measured on section, and the nearest angle of slope in degrees in the table used as a starting point for the design. The table demonstrates that with shallow falls, which apply on pavings and ramps, the most practical method of specifying the slope is to give a proportion, i.e. 1 in 60, rather than quoting degrees or percentages. More discussion of paving slopes or gradients is found in the seminar on drainage. Avoiding unnecessary steps is more than just a matter of safety. Since 1999, access paths to all new housing from the street should be designed without steps wherever possible, and with a minimum width of 900 millimeters to allow 2 people to pass. The emphasis on ramps to overcome small differences in level will benefit not just those with walking difficulties, but also those wheeling prams, wheelbarrows and children's bicycles, to mention just a few. Obviously, the 900 millimeter width need not apply to occasional use paths in domestic gardens. In a public place, where 2 wheelchairs or prams may need to pass, the preferred width should be 1.8 meters. If you intend users to take an additional pace between risers, add at least 650 to 700 millimeters onto the tread dimension. If in addition you want to combine steps and a ramp to form a stepped ramp, then a dimension of between 1 meter and 2 meters between risers is required with a maximum gradient of 1 in 15. Although not ideal, it is possible for wheelbarrows, lawnmowers, pushchairs and prams to be wheeled safely up such a stepped ramp for a distance perhaps up to 12 meters. The general limitation on the use of ramps is not just that there is sometimes a legal limit on steepness, but also the longer ramps need intermediate level resting places. The steeper the ramp, the more frequent the resting places. The rule of thumb for the length of ramp before a level resting place is required is shown in this table on the screen. Level resting places reduce the effective slope of the ramp. The purpose of a balustrade or guardrail is to provide a barrier to protect a change of level. A handrail, on the other hand, is primarily to assist the climbing or descent of a ramp or flight of steps by providing a handhold, but it may also act as a guardrail. The risk of falling needs careful assessment. The assessment should include the range of possible users, such as the very young, the very old, or the disabled. Remember that even a small change in level of 25 mm is enough to sprain an ankle or cause a fall, especially if it is not clearly visible. If the vertical drop to be protected is less than 600 mm, you may consider that it is sufficient to protect the drop with planting or perhaps a bench seat. It is important to guard with a balustrade or handrail where the total rise of the steps is more than 600 mm, or there is a drop of more than 600 mm at the side of a ramp, flight of steps, or balcony. The handrail height on steps and ramps should be 900 mm, measured vertically from the nosing of the steps or surface of the ramp. The rail should be 40 to 50 mm wide for easy hand grip. A balustrade should be 1.1 meters high for protecting the edge of a balcony. The illustration on the screen shows a typical section of a timber balcony balustrade. The top guardrail or balustrade must be strong enough not to collapse if several people were to collide with it simultaneously. A horizontal force of 0.74 kilonewtons per meter is the appropriate test load applied to balustrades. Meeting the strength requirement should be no problem using a proprietary railing system where the manufacturers will have tested their own product. For purpose-made timber balustrades and guardrails on terraces and balconies, the following table and details will assist. The minimum cross-section of a balustrade in order to provide the necessary strength will depend on how frequently it is supported. That, of course, is the same as the spacing of the posts. You therefore have the option to choose a balustrade rail size from the table at the top on the screen. The balustrade rail you choose will then determine the post size and spacing. Alternatively, you can consult the lower table, choose a post size, grade of timber and resultant spacing, which will then dictate the appropriate balustrade rail dimensions. Where young children may be present, balustrades and open tread steps should not have a space greater than 100 mm to avoid the danger of getting children's heads stuck or of them falling through the gap. The use of glass or plastics in barriers requires British Standard 5250 safety glazing material, that is to say, either toughened or laminated glass or shatterproof and UV light resistant plastic. The secure and weatherproof fixing of glass is also a specialist matter, which should be entrusted to experts.